Good morning, students. I am Dr. Vijay Bandari, Associate Professor in SIRTS CSE Department. Now, we are going to perform experiment number 10. The name of the program is Implementations of Upper Confidence Bound, that is in short UCB, using Python. So, okay, it is a type of reinforcement learning. So now before we proceed, the implementation of Upper Confidence Bound. So I will tell you about Upper Confidence Bound. Okay, so it is a type of reinforcement learning, and the agent or decision maker generates training data by interacting with the world. The agent must learn the consequences of its actions through trial and errors, rather than being explicitly told the correct actions. Now we will talk about multi-armed bandit problems. Okay, so it is also a reinforcement learning, and sometimes we use multi-armed bandit problem to formalize the notion of decision making under uncertainty using k-armed bandits. A decision maker or agent is present in multi-armed bandit problems to choose between k different actions and receives a reward based on the actions it chooses. Bandit problems is used to describe fundamental concepts in reinforcement learning, such as rewards, time steps, values. So now imagine an online advertising trial where an advertiser wants to measure the click-through rates of three different ads for the same product. Whenever a user visits the website, the advertiser displays an ad at random. The advertiser then monitors whether the user clicks on the ad or not. After a while, the advertiser notices that one ad seems to be working better than the others. The advertiser must now decide between sticking with the best performing ad or continuing with the randomized study, which we will look in the implementations of upper confidence bound UCB. If the advertiser only displays one ad, then he can no longer collect data on the other two ads. Perhaps one of the other ads is better. If only appears worse due to chance, if the other two ads are worse, then continuing this study can affect the click-through rate adversely. The advertising trial exemplifies decisions making under uncertainty. In the above example, the role of the agent is played by an advertiser. The advertiser has to choose between three different actions to display the first, second, or third ad. Each ad is an action. Choosing that ad yields some unknown reward. Finally, the profit of the advertiser after the ad is the reward that the advertiser receives. When we have what we have discussed in this experiment number 10. So, what are the actual values, and what we will talk about the actions values. So here, the action values is for the advertiser to decide which action is the best. We must define the value of taking each action. We define these values using the actions value functions using the language of the probability. The value of selecting an action's Q of A. Suppose Q of A is defined as expected rewards are we receive when taking an action or perform the possible set of actions. The probability distributions for the reward corresponding to each layer is different and is unknown to the gambler. That means decision maker. Hence, the goal here is to identify which to pull to get the maximum reward after a given set of trials. Now, we will use the formula of actions value estimate. Since the value of selecting actions Q of A is not known to the agent, so we write the sample averages method to estimate some of the rewards when A and T prior to T. It will be divided by number of times T prior to T. So this is all about the upper bound confidence bound UCB reinforcement learning. Now we perform it on the Sublime text editor and get the results. Now we first importing the libraries, import NumPy, Matplotlib, PyPlot, and importing pandas. So pandas to creating charts, and Matplotlib for the creating charts, and pandas is used for the reading a file. Okay, and NumPy for the calculations or mathematically performing the operations. Okay, so now we importing the data sets, and here the data sets downloaded from the UCI machine learning. Now we can see here reinforcement learning, upper confidence. This is the ads. Add 1, add 2, up to add 10, and these are the categorical values. And now we see here importing math, and these methods are applying on these techniques, like some of the rewards, number of selections, add selected. Okay, and we start the index value 0 from 0. Okay, in Python. Now we plotting the histograms, add selected, number of histograms of add selection in x-axis, and number of times each that was selected in y-axis. So we renaming these titles on x-axis and y-axis. So now we use the plt.show. This will show the plots, okay, and which we are doing, applying on the methods of number of selections, rewards, actions. Okay, so now we run this code and getting some good results. These are the histograms of add selections. Okay, so 0, 4 to 4, 6 adds. There is adds, and these are the number of times this add was. So here this histogram of selection is better than these. So this is the histogram of add selections, and you might be understanding this results. If any doubts, so please ask me. Thank you. That's for the day.